Welcome to a new test and teardown video. This time it's a Nixie clock. Yeah, I'm sorry it's hard to see the tubes. Oh, this one is from a ship and it's very, very old. And it looks like it's German and English text. It's engraved. We don't know the company name or anything like that. But it's probably not German made because they don't know how to spell. So we got some minor spelling issues. You can probably see here. Yeah, it's funny, but there's not supposed to be this space here. And it's the same here. But well, they should know. So here is this model is SM-1D. Yeah, it's a little bit loose. And I definitely need to open and inspect. This looks like salt water or salt mist. Let's open and inspect. It looks like we got some screws loose here. There's only one screw. And that is what we got. Some screw terminals, and then nothing else. How do we figure this out? That is some beautiful Nixie clock. And it is very, very old. A lot older than I first imagined. Ooh, we got some broken resistors, definitely a little bit overheated. Is this capacitor supposed to look like that? We got some relays. Yeah, I better take some photos about where is everything. Oh, look at that transformer right there. And it's directly driven with... This is a funny driver chip. And it's in SMD. Really? So this looks like 4 bits in, and then it drives the Nixie. How about that? But still, I haven't found any kind of text that reveals any kind of brand name. And this, with this bent plate and the regulators and all that. Oops, what is that? Is that a backup battery or some sort? Ooh, I hate stuff with batteries in it. This is some really funny old looking battery. I better take that out. I need to remove batteries from all sorts of funky old stuff. So here is the bottom view of this unit. So I still haven't found the crystal yet. At first I thought it was this one in this socket. But I will show you something in a second. We probably got some leaked capacitors or something leaked down there. Look at this corrosion around this screw, and this one is really, really bad. So I need to remove those 2 screws and figure out what is going on in this area. The wiring here is neatly fixed. Except for those 2 wires here. I don't know exactly what's going on here. We got some fuses. And everything is just going back and forward in one big mess. Instead of going exactly where it's supposed to go. So this is a way to make all wires as long as possible. And to create as much coupling and crosstalk and whatnot between everything. It's not super good when it comes to anything like that, but there's not a lot more to see here. I just need to figure out how do I power this up as well. So the mains transformer, and where is what here? That will be the two transistors for the power supply. Yeah. Okay, so that was quite easy. I just figured this out. Okay, so here's 220, and it's just going here, and here we go. So that should be exactly what I need to know, right? But there's also this. That is chassis. So that would be my earth protection. Okay, and then the rest is low voltage control, some external clocks with some pulses and all that kind of stuff. In the old days, the remote control clocks, they were like pulses back and forward, so you can set and run external clocks. But at first I thought this would be the crystal, but that is not the case. Look at that. It's one of those indicator tubes. But why? And what is the point? I am a little bit, in shock to see a tube like that right here. Is this really the right tube? Or what is exactly going on here? It's EM84. Yes, EM84. It's a beautiful readout tube. It's a little bit brown, but with some really bent legs. I'll fix that in a second. Yeah, I better try and pull out all the circuit boards, but look at that. It's really, really badly corroded down here. And the corrosion I was talking about with the two screws, well, that's just the standoffs. See? Completely nasty corroded. So I think I got enough pictures here to realize how to put everything back together. But maybe let's just have a little sneaky peeky here. Look at those ICs. It's full of SMD. This one looks like the lid is coming off half the way. And that is the crystal. So we got some counters and dividers and all that. And that trimmer here is really, really difficult to reach. That is a really dumb design. Let's look a little bit on the display board here. I think I earlier in the video was yelling a little bit about, oh, this is a Nixie clock and all that kind of stuff. But it's not Nixies. Those are VFDs. Let's look a little bit here. We got some Chinese names and numbers, and then it's called, what is that, YS27-3 or something like that. Maybe this 82 is the year. Maybe it's not as old as I first imagined. But as you can see here, those are VFDs. Definitely. And there is a control grid as well, and then the filaments. It's a little bit rare to have that for direct driven single, but this is there. Of course, you can also multiplex them, and then you need this control grid, as you can see. And then you got the filaments. So it's going to be interesting. What is going on here? And those chips, I mean, it's getting more and more weird. Look at all the chips. So what is this, Chinese or Russian, or what is the origin of this product? I need to try and look some of this up. Maybe I can figure it out, but maybe we can get some clues by looking at the transistors as well. We got some really, really interesting names and numbers here. Oh, let's show a little bit of this mega mess I got myself into here. So where do we start? Well, This, where is it? I think this circuit board here is a little switch mode power supply. Maybe this is the one that is making the filament voltage. And this makes a little bit sense because it's a very, very low voltage. And it's a little self-oscillating drive. And a little, I think this is a flyback type of drive, because there's only one power transistor driving one end of the coil. And then we got some other transistors. It's probably doing a feedback of the flyback voltage of that inductor. So it's a quite smart way to regulate and oscillate. And yeah, this is where we had a very, very burned resistor, and I don't know the value. I just guessed, well, 1 ohm. Let's just put in 1 ohm, because this track was at some point shorted, and then they just put in a resistor, probably just so they can measure the current consumption of this little converter. So this is just my guess what is going on here. We don't have any schematic. We can't even look up any of the parts, basically. And this one is just a little relay board. I bet this is just doing the forward and the reverse control of a remote clock. And again, look at those beautiful Chinese transistors. Everything here is Chinese, by the way. I see some Chinese signs. They're really weak. And on the original capacitor, that was also blown up. That was with the Chinese signs on them. I should probably go and show you some of the little beautiful capacitors. And the VFD board, I cleaned the tubes nice and shiny, and look, I also cleaned the glass here, so now we can see through that. Yeah. And then all these boards had blown up capacitors. And see, I put in some new. I have no clue what this board is doing. I can't Google anything at all. Again, either Russian or Chinese ICs of whatever sort. I don't even know what kind of voltage we need to drive these with. No clue whatsoever. So how can I verify the power supply is good and up and running? Yeah. This is going to be a something I really want to see if that is possible. And that is the oscillator board, also with a blown up capacitor, 2 blown up capacitors. And they're using a little LED for indicator. So that is... they're not using it for to indicate anything, I bet. Maybe just to indicate there's a current going on in this circuit. But I think this is a voltage reference for the oscillator of some sort. It's a little bit weird, but I have seen LEDs used as Zener diodes. And then, see, again with a capacitor that was blown up, I also replaced this. Another funky board doing some maybe dividers or something like that, right? We got the same sort of ICs more or less all over the place. Yeah, I cleaned the contacts a little bit. Yeah, and here, the capacitors. See? Chinese brand. And it's just, yeah, also here. On the top. Luckily they are writing down here 100 micro 16 volts, so they're quite easy to replace. Can I hold this? Yeah, anyway, this is a little bit boring. It's more fun to talk about this big hefty battery pack here. And there was 0.2 volts on this entire pack. But I think we got more than one cell. Look at that. So I will try and open this one and see what's going on. It's also leaked. So I better take this out and count how many cells and just write down here with a permanent marker how many cells. And I bet this is just to run this internal mechanical clock, so you can use this to set the electronic clock. But we also got a little bit of extra wires going in and out of that one, so there's probably a little mechanical switch or maybe a auto reset, auto set from the mechanical clock to the electronic clock. I don't know anything about that yet. So this I need to do. Well, that was some really nasty, sticky stuff to get in here. But what we got is 9 cells. I bet this is a 1.5 volt each, maybe. I really don't know what kind of technology that is. But it needs to go to battery recycling right now. I realize I can't look up any of the IZs or anything here on any of the circuit boards because nothing gives me any kind of hits. So it's either old Russian or old Chinese ICs. It's just impossible. But we got the EM84 tube in this socket. And I just added here a little number 1 and number 9, so it's easy to visualize what is what. And if we look at the EM84 pinouts, we will know that between pin 4 and 5 is the 6 volt filament. So let's count 1, 2, 3, 4, and oops, 5. No wires on 5 and 6. So it cannot be an EM84 tube. It just makes no sense. No wires was removed here. I carefully cut this out here and have a look. There's nothing. So what is going on here? Now that was my last clue to figure out any kind of voltages out of the power supply. And this is the power supply that has been blown up. The Zener diode was blown, is shorted. This transistor was shorted, and this was the BZ557 PNP. And this the other one I cannot look up. I bet that is also a PNP transistor. So what I'm gonna do is I'm gonna put in the same transistor over there and then see what happens. All those resistors, they look a little bit brown and nasty, but I think they actually turn out to be okay. All those capacitors, they're okay. So I'll try and put this in. Measure the output voltages. It's quite easy to follow the wires here of the transistors and all that kind of stuff. And then slowly crank up the voltage while I measure what is going on. Because I don't even know what is the right voltage. So when will I know if this is working or not working? This is not funny at all. It has been driving me nuts, this glass. You can't really clean it from the outside or the inside. I mean, yeah, you can only do that but it's two pieces of glass. So you need to take away the entire front panel to remove this little piece of metal that went in and was rotated, and this locks the glass. And I even had to take away the hands. They're lying there, and that will be the analog clock. See, they painted it here, so now I can also clean all this nice and fine, including the clock glass and all that. It can be nice and beautiful again. So here is what I've done. After all this nice cleaning, you can really see through the glass. Yeah, you can even see me here. It's so nice and transparent. Look at that. That's some big difference. So, I mean, if I can't make this work, it's still going to look real nice and pretty. At least I can be happy about that. So, what I have done now is I'm measuring the battery voltage. I removed the battery, and I'm also monitoring the voltage over the ICs. So I soldered a little monitor voltage over these are all parallel with the, I think that is the voltage. That'll be the battery. That'll be the mains entry. So I just slowly crank up the voltage, mains voltage, and then I will see what happens. I will monitor if there's any light in the filaments. If there's too much, they should be only barely visible. So that is why it's very important that I monitor this and be ready to turn down the voltage. I will also grab my thermal camera and monitor the different components in the power supply as well. So let's try and see what happens. Okay, we are not using any kind of power that I can measure, but I get voltage. That is interesting. I got something is going on here, but it's not using any kind of readable power. Really? So, I mean, that proves my fuses, they're good. So the voltage on those ICs, that's probably a CMOS. So it's 7 volts. I should probably put this one right here. And we got 7 volts on the battery. So let's turn these off. And let's go a little bit more. So it's probably, I hope the voltage is going to regulate at about what, 10, 12 something. Why isn't it not? Yes, look at that. 14 volts regulated, and now I continue my voltage up. And everything stops at 14. Wow, look at that. So I should expect, and it's only using 1.9 watts, that is exactly what I want. So what if I click the display button here? Okay, there could be some sort of power on stuff. This is a little bit interesting, but at least I got voltage. Let's continue. And this is the filament power supply, and it was completely broken. I had 0 volts on the VFD filament, and I replaced all the transistors, and also there wasn't any local decoupling here. You can probably imagine the little oscillator here. We got the capacitors here and capacitors here for the phase. Look at that. Phase, and then gain, easy, and then the driver transistor right there. And all those transistors on this one, I believe, is NPN, because the way that it's connected like that, we had little letters on the circuit board. And we also got a -19 and a +14. This is just the resistor value of 1 ohm that I just guess it could be. So, yeah, that will be all the original transistors. Let's try and see what happens now. So now, let's try and see what happens. We got too much filament. Can you see there? The light in all the filaments. Ooh, I should probably crank this down. Yeah, they're not supposed to be that visible. So now I changed the series resistor from 1 ohm to 18 ohm. And let's see, yes, they're still really bright, those filaments. So I need to change the resistor again. So that is 47 ohms, and let's see how that is. I still see those filaments shine a little bit too much. I'll just continue until they don't shine that much. So look at that. Now we got the time, and the filament is just barely visible. If you go really, really close, I don't know if I can show this. Yes, I can. That is the right voltage. I mean, normally I would maybe adjust it a little bit lower than that. But if I do that, the VFDs get really, really dim. So now it's all about, can we make the damn thing? Okay, so this is setting, and then this hours. No. Oh, look at that. We can do this at a set time. Yeah. So that is the minutes, and then hours, no. Seconds. That's maybe. Or maybe we need to clean the switches. But there's definitely something that is working. And then stop. Maybe you need to do. I hear some clickety relays and stuff. I need to figure out what's going. So this is if I. Why is it not running? So we have a missing clock. But I'm definitely getting a lot forward with this thing. I am so sad that I cannot find any kind of data about those ICs and all that, but maybe there is a way to figure this out. Maybe I can start to measure what is going on in the oscillator board, because I know what the board is, the oscillator board, right? And it's not generating clock, or something is not counting. So I believe that I can get this one up and running sooner or later. I just don't want this video to be any longer than this. It's already super nice that we got something on the screen here. So you can probably imagine me playing around with this a few more days, figuring out what is going on. And if there is any fantastic updates, I will just add it to the description. I think that will be it. So thank you very much for watching so far. Bye bye.